Okay, this is SHellam Abraham, and here is my entry for HackFest for KansasFest 2020. This is called the MesmerizerExorciser, and what this does is just allows you to basically veg out with the Apple II using screen flipping, page flipping. So what this is doing is it's flipping the pages of the screen very rapidly between a page filled with two different characters. In this case, it's one page is filled with spaces, and the other is filled with inverse spaces. And so as I'm using the arrow keys here to go back and forth, I'm getting different patterns as it's flipping between them. And here we have a freeze frame. Now I can use the up and down arrow keys to change the background character. So as you can see now, or at least the character on one of the screens. So right now the character on one of the screens is being changed. And then if I want to change the character on the other screen, I press return, and then that allows me now to change the other character. And then I can go and flip between them and find different effects that do weird things and interesting things, and there's plenty. And then of course it's poking the speaker every loop, and so it's making this annoying sound. So that's all fun and dandy and interesting and everything, but I thought, well, that's not very exciting after all. It's just page flipping. And here's the code, just to show roughly how much code it is, and I'll get into what's going on here in a second. Oops. And it goes all the way to, in this version at least, goes all the way to, it ends there at 3C9, right? So if we run this again, one last feature I should show is that this has a feature where you can print the parameters, which are stored at 6, 7, and 8. And that's the 6 has the loop, the delay between flipping, and then these are the two characters, right? So you can record the parameters and share them with your friends. Now, okay, so that's all great and everything, but it's is it a HackFest entry worthy of much of anything? No, I say. So what I did is, let me boot into my booty here. I did something more interesting with it. So let's change our boot volume here. Now we're going to go into what I did with it, which is I turned it into a 2-line basic program. So in order to stuff all of that code into a 2-line basic program, I had to do several things. First of all, I had to cut out some code. So I cut out the part where it prints out the parameters, right? That had to go. And then I also whittled it down, took out a bunch of checking for this and that and the other thing, whittled it down to the bare minimum. And still with that, I got it almost exactly perfectly fit into 2 lines of basic code. There's I believe there's either exactly 239 characters up here, it might be 238, but there's exactly 239 characters here. And what I mean by that is when you enter a basic program line, you can only enter 239 characters that will be interpreted by the interpreter. So you can enter 240 characters, you can actually enter up to 254 or 55, I believe, but it starts beeping after 248, or at 248, but anything past 239 will be ignored. So this is exactly 239. Now what's going on here, there's a few things going on here. So the question is, how do you get 300 to end up being 146 bytes into 2 lines of machine code into 2 lines of basic memory, right? Because you have to do pokes and all that stuff. Okay, well, there's been different techniques that have been invented over the years. One of them is the SHellam method, where you basically poke a string into memory, and then you call the routine in ROM that will interpret that line as if it was entered from the keyboard, and then execute it. Well, I took that and made it even more efficient. I call this the SHellam method. So that's a play on SHellam plus my name, SHellam, combined it. So it's the SHellam method. And so what I'm doing here is I'm setting things up so I can print right into memory, right? So that is the vector where the base address for where the next text output is going to go is stored in 40 and 41, right? Locations 40 and 41. Well, that's what home is doing. What home is doing is it's poking a 0 at 40. And why didn't I just say poke 40, 0? Well, because that takes 4 extra characters, right? So that's what 2-line programming is all about, is absolute efficiency, finding different ways to do the same thing. Well, that's what I'm doing here. Then I poke 2 at 41. So what that's saying here is the base address for printing to the screen is going to be now set for location 200 hex, 512 decimal, of course, which is the keyboard buffer, right? And so all that's left to do now is I have to poke 33 of 255. That's the screen width. So what I'm telling it is basically don't carriage return. As long as this string is less than what this value is, the length of this string is less than this, then it won't carriage return, or which will cause the base address. This base address will change to something else entirely, and you won't have contiguous code in memory, so or contiguous string, which won't work. Anyway, trust me on that. You need to poke the 33 of 255 so it won't carriage return. And then so after we set the base address and do that, now we just need to print. And so now here we're printing this string of bytes here, hex code, which starts putting bytes into memory at C9, and I'll explain why in a second. And so there's our code, and ends here with this end C9 go, right? So it's going to execute the code at C9 after it puts it in. And then this call -144 is what actually will then interpret this, put it into memory, and then execute that. And so then we have a colon, which actually wasn't needed because A will act as a delimiter also, but in this case we had the luxury of putting a colon there. So what's happening here is then, after that, BASIC is never going to touch this, right? So it doesn't care, and it's just straight ASCII. And so what this code is doing is it starts here, and it starts reading these characters and interpreting them back into hex, and stuffing them into 300 in memory. That's right here. No, that loads it. Anyway, so then it gets to the end here, right? And notice that there's a AD. Well, actually, just to show you that this is the start of the code, there's an A909, 8506. So that's load A, 0 page 9, location 9, store A, 0 page, location 6, etc. Right? And then over here we have an AD00. So AD is load A, absolute. So we have AD00, but we got a page break or a line break, and then we continue over here, right? So AD00C0. Well, this line break is taken care of with the code right here. So this basically says this code right here changes the starting address of where we are to continue reading, basically right here, and then it loads the Y register with where we're going to continue reading, and then jumps back to the beginning of the loop. So that's this code reading this code. It reads it all the way in. There's a 60 right there. You see that's a return subroutine. Anyway, so when I run it, it's going to put this into memory, this loader. It's going to load that loader, run that. That loader is then going to load this and run that, and then we're going to have our MesmerizerExorciser again. So ready? Here we go. And there it is. Now it operates a little bit differently because I noticed in the first version I wasn't I was doing my loop wrong. I was flipping the pages and then going back and doing all the keyboard checks and all that, and I realized, oh wait a minute, that's an unequal amount of delay between the page flips. So this actually does an equal delay between the page flips. It's flipping the page every other press of the key. So and then of course we can change our background character. We press return. We can change our foreground character, and we can, as you can see, we can get just really bizarre effects. The camera doesn't really. Yeah, there we go. You can really get some neat things going on. I'm changing the back one character. I'm changing another character. There's an interesting thing right there. Just set the delay really high here so you can see some flipping going on there. There you go. There's a slow motion flip, just reversed. And oops, let me change this character to something different. So anyway, so there you go. And now when I press escape, it does that. And just to show you the remnants of the code that's still in memory here. So if we go to C9, now I put it at C9 because, so first of all, the reason is B1 is where the code, the basic, the get next token code is, right? So I put my code at the very end of that. And the reason I did that is because by putting it in 0 page, I can take advantage of a couple things here that needed to do a 0 page address, like actually at the end here. It was less bytes to put it in the 0 page instead of somewhere else in memory. So that's why I put it here, because every byte counted when I was trying to stuff it into those 2 basic lines. Like literally everything converged into this perfect, everything just worked out like at multiple dimensions. I can't even begin to explain. My brain is so scrambled because I've been working on this literally for all day. So anyway, so there's this is the second stage loader. The first is the basic program. This is the second stage loader, which, yeah, as you can see, it's taking bytes from the basic it's then converting them into a value, hex value, that's then stuffing into memory up here, and then down here there's that code that checks to see where we are, crosses the line boundary, when we skip from line 0 to line 1, that's what's going on here. And then the code for MesmerizerExorciser is right here in memory, and there it is, all poked in and looking beautiful, and ending actually, the old code is still in memory here. But anyway, that's it. This video is way too long. Thank you very much. Hope you enjoyed that. Bye-bye.